get to see a lot of nice people like yourself in universities and students studying, and it's nice to be able to come in and bring a company so you can see some of the things that we're doing in industry, and it can excite you and get you passionate about your studies and the things that you're doing. So my name is Karen Meisman. I'm from Materialize. I also have Stanley here with me, who's the account manager for your university, and also Farina, who's our application engineer and is going to give you all the how-to-dos. She's the reason that I don't need to know about finite element analysis. So she's going to help you with all the details about that. But let me first of all introduce my company. And the name of the company is Materialize. We're known as innovators you can count on. One of the reasons is, some of the things we heard in the last presentation, is technology is typically at a certain level, and we're challenged, and the new ideas really come from all of you in the universities and research. And that really stretches us to really go beyond what's possible today. And that's where new ideas, new research, new softwares come with new capabilities. So let me tell you why we're known as innovators you can count on. It all started, there we go. It all started with a man named Van Fried. I forgot his last name. Yes. And he's our founder. So he started Materialize 20 years ago. And it started in a very exciting way with one machine and one man. And this machine is a rapid prototyping machine. Has anybody ever heard of rapid prototyping? Yeah, you use it? So you have it here at the university? Yeah, okay. Now it's come to where it's being called additive manufacturing. And I'll get into a little bit of why that is, but one of the main reasons is because it's no more just used for prototyping. So he started with one machine. He had a dream. He had it in his basement, and him and his wife worked on it. And at that time, there was no software that really ran it well. And so it was really a challenge. Some of the things that today that we can do in 5 minutes would take him months to do. So with this one machine and a dream, he started Materialize. Materialize has now grown, after 23 years, to a worldwide company. All over the world, our headquarters are in Belgium, and we have over 900 employees. So as you're sitting there today, you might be thinking about ideas for a business or for some new idea. And that's how it starts, with a vision, and with a dream, and with just applying yourself to the technology that makes it possible. As you can see, we're all over the world. We're here in Malaysia. We have an office in Malaysia. We're in the countries where the people are doing this research and speaking in their language. Our mission at Materialize is to use this innovation, these products, to create a better and a healthier world. We live in a world that's constantly changing, but how can we, with our technology, impact it in a better way? And one of the ways that we do that, there's many ways. One is with finite element analysis and design and measuring, but one of the core ways that we do that is with something called additive manufacturing, or 3D printing. And this is kind of what it looks. How many people have ever seen a machine making a 3D printing? Raise the hands. Anybody seen it? Okay, just a few. This is one of the examples. This is with a liquid vat of polymer. And so a laser goes around the top and hardens it. There's other methods. You can use powder or acrylic. But let me show you a short video to show you exactly how this works in a machine in our headquarters. The bottom thing. As you just saw on the display. So that's just a short video so that you can see how that works. So now everybody, next time you're asked that, can at least say you saw it, even if it was on video. Next step is to see it live, right? Okay. Now all around the world, we're hearing front page news in the news all about additive manufacturing. 23 years when we started, nobody heard about it, nobody was talking about it. Now it's all the rage, as if it just happened. We've been working in this market for 23 years. These are some of the products. They range from a functional product to an art product to things that we see in museums, things that we see in galleries. But the thing is that all of these are possible by taking designers and engineers. We're looking at all different ways that engineers can impact our world. And we're starting to see these all over the world in galleries, in people's homes. It might be even products that you see every day, that you use every day and you don't even realize it was made by additive manufacturing. One example of this is the hip. This is a hip implant over here, a hip implant. Has anybody ever known anybody that had a hip or a knee implant? Huh? Yeah? Maybe someone in your family, okay? This is an example of a hip implant that was designed in our software. The thing that's unique about it, it was customized to fit a specific patient. It wasn't just an off-the-shelf implant. Implants today can be customized to a specific patient, or they can take a standard one, and using FEA, they can optimize it, or they can customize it, take a standard and change it a bit to customize it to more of a patient population. Or we can look at a wide range of patients, say in the Asian population, or maybe specifically in Malaysia, and we can say, what is the best fit for this population of people, rather than just the average guy implant that we've been using for years and years. Right, here's an example of hearing aids. Today, 98% of the hearing aids in the world are made with additive manufacturing. Maybe you didn't know that. And Materialize had a part in that. We had a collaboration with Siemens and Phonex, and we created a workflow in order to build hearing aids using additive manufacturing. They used to be made by taking impression. I mean, that's how they're made today. I'll get to that, by making an impression. Used to be you take some wax and you carve it off and carve it, keep shaping it, put it in until it fit pretty good. Based on that, you would create your design and then build the model. If the patient lost it, you had to start all over again. So it was very expensive and time consuming, and times they would go without it for long periods of time. Using a digital format, we take an impression and then we digitize it. We scan it, we bring it into the software, then we have a permanent file of that patient's anatomy, and we built the software also to do it. So all of the process along that flow was created so that every step of it, all of the components, all of the building was built within a software flow. And now, if a patient loses it, no problem. Come in, we have the digital file, we just build another one. So now that's an impressive number, 98% of the hearing aids around the world. Another example is phone cases. Everybody's got a phone case. I got two. Chances are they were made with additive manufacturing. Even the phones themselves, the casing on the phones, it's no longer just a prototype. It's being used in production. Cars, the parts, the new designs, they're made with additive manufacturing. We're working in collaboration with top orthopedic companies around the world in partnership to build guides. Doctors using software that we developed are planning surgery. They're going into surgery with their plan and guide. They set the guide on the bone, they cut where they planned, they drill where they planned, and they put the specific implant in the patient exactly where they wanted it. The goal is that through studies, through finite element analysis, we'll see that we'll be able to keep implants in patients longer. Athletics, younger people are starting to get implants. How long are they going to last? We need them to last longer. We need them to last years in the future. So whether it's a functional design here, and this is a stool, you pick it up, it comes together and folds, all was built in one build. All the moving parts, all built in one build on an additive manufacturing machine. So we can build in functionality that was never possible before. Or if it's this implant that was customized to a specific patient, the thing that they have in common was the engineering that made it possible. And that's where you all come in. And where are you going to take it in the future? So why are people turning to additive manufacturing? What's so exciting about additive manufacturing? We have ways of making things now. Why additive manufacturing? One of the ways is it adds value. It improves the quality of life. If you can have a personalized hearing aid and put it in your ear and nobody sees it and it's comfortable, that can change somebody's life. It can also create the impossible. It tears down the border of what's possible in the past. Also, prototyping is still needed. So we still want to build parts that we can take and test them before we build the actual part. We save lots of money if we can test the fit, test the strength, things like that before we actually go to manufacturing. Reducing parts. If a surgeon's going to surgery and he knows exactly the implant he's going to use, he doesn't need to take all kinds of stock with him. Even parts that can be built on demand that we don't need shelves and shelves of parts. And then also mass automation, using this technology to create mass, customized automation. What about this green we hear everywhere? Everyone's talking about green, right? Helping create a better world by reducing less product that we need to build something. Taking less product takes less energy, takes less materials, less cost. And if we can create a product that's strong, yet decreases the amount of materials we need, if we're putting it in a patient, if we're putting it in a car, if we're doing impact testing, if we're creating better vehicles so that when there are accidents, that there's less injuries. All of this is possible with additive manufacturing. You can create something unique. At Materialize, you can now go to what's called iMaterialize. And it used to be that these tools were just a toolbox that no one like me could understand. But now you can go to iMaterialize and you can create your own design, a personalized design with tools that are easy for just the average consumer to use and build something personal, a piece of jewelry, a gift, something like that. Or if it's a customized fit, you now have an implant that's going into your head, and you're designing your face so that you look like you looked and you don't now have a defect that causes you to look aesthetically different. Or the mass design of something, maybe going into business and creating a lot of something in a unique way. And how can we help? How can Materialize help? If you think about it, what I'm seeing in Asia is what I call a leapfrog effect, where some of this technology has been going on, it's been proven. When I talk about surgeries, where we're using guides, this isn't science fiction. This isn't something that's happening sometime in the future. Hundreds of thousands of people in the US and Europe are having surgery with these guides. This is happening today. And now as I see in Asia, we're starting to become aware of it here, and we want to enter into that market. But there's a knowledge gap and there's a time gap. Because in the US, I was involved with it 13 years ago. And incrementally, we went step by step into the new technology. And we tried something and we outsourced it and it worked and we brought it in-house. But now it's already been proven and we're already there. So how do we get there quicker? How do we bring Asia up to speed without losing the time and the momentum that we have now? And it's going to take all of you with the passion to move things forward. But Materialize can help because we have 23 years of know-how. So how can we take that know-how, bring it into the universities, make sure that the universities know what this and have the tools, the software, the technology, the support of us to be able to get them where they need to go. And why can we help? Because of our 3 core competencies. In Belgium, we started out with 1 machine. We now have over 80 machines. We have a virtual machine park there, a factory of the future, which are building parts of every type of machine and every type of material possible. It's possible to build the metal implant I showed you, the implant, that was metal, that was built on an additive manufacturing machine, building in metal, not in plastic. All of that's possible, it's being used, it's being implanted into patients. We have the know-how and the expertise. We not only sell software, we sell our know-how. So one of the things when Fried first started out with his 1 machine is it didn't work with current technologies. So 2 master students that were at the University of Leuven where he started wrote the software. One wrote our software Mimics, and one wrote our software Magics, and they're both with us today as high-level vice presidents in the company. And that's something that you can all be thinking about too. What's the needs of the future? And so with this technology, we're able to not only use it ourselves, but we allow others to use the technology that we created in their universities and their businesses to develop their businesses. Our other core technology is digital CAD. So you work probably with CAD software, right? Digital CAD is taking an object, and instead of representing it as a CAD object, we represent it with triangles. And so with triangles, which are called STL files, you can get very, very small details that's not otherwise possible with CAD, especially when we talk about the anatomy. Our Mimic software and our Freeman that work together, they were specifically designed with the anatomy in mind because our body is so organic. The shapes and the different densities of materials, it's different than a material like a metal. It changes wherever you are in the body. So we use this digital CAD for automation. And an example of automation is the hearing aid. And just as I explained, we started with the impression, digitalized it, and went all the way through the process into an additive manufacturing shell. Our other core competency is medical imaging. By medical imaging, I mean MRI or CT, 2D stacked images that we bring into our software. And by bringing in the 2D, we're able to create a 3D and visualize the invisible, what otherwise couldn't be seen. Opens up all kinds of possibilities. So we can take that and engineer on the anatomy. So now we're not just engineering on a model that looks like a person, but it's an actual person. It's either an average of multiple people within a population, or it's a very specific person. And with that, we can also create physical models. These physical models you can hold in your hand. You can see a heart. You can see where the valves are. A doctor can explain to a patient, this is the surgery and this is why it's needed for your baby. Or it can be used in education in schools like your own, where you can see inside the body for the first time. You can hold the model, open it, you can see what it's like inside, and touch it here. These little models overlap, and where they overlap, that's where our strength is, and that's the strength that we bring to industry and also to universities. Because what I'm finding in universities is there's not just one discipline. And as someone mentioned, there's this interdiscipline where we need to work together and collaborate. And it's when we bring all of these talents, all of these skills together that we really have something that makes a difference in the world. We also take all of this knowledge, all of the abilities of our software, and even all of our research that's going on in the future, which no one's even talking about yet because we're off in the future doing research. We can take that and do services for people when they have ideas of things they want to do or businesses they want to build or directions they want to go. But the difference between us and, let's say, for example, Apple, is Apple uses their technology all for themselves, which is great. I love it. I have an Apple phone. I love their technology. But if you compare it to Samsung, they have an open technology, which they have a technology which they allow others to use in their products to build their products and their future. And that's similar to what Materialize does. We decided from early on with that one machine that we weren't just going to take the technology and keep it for ourselves, but we were going to expand it out into the world so other people could learn from it and build with it. Because if you think about it, if our mission really is to create a better and healthy world, are we going to do it all by ourselves, or do we need everybody else to do it with us? So creating this better world is a world where designers can design better products that we use every day and improve the quality of our lives. It's a world where companies can better serve and support their customers. From the inception of a design all the way to the manufacturing of it, we have processes in place that can help them to track it and to monitor the quality and to go to manufacturing. We're patients be treated with a personal touch. And isn't that what we all want when we go to a doctor? If you look at something in additive manufacturing, I told you on our Mammoth machine, we can build a full body. We have a statue in our headquarters. It was built on our Mammoth machine. Or we can build the smallest little part that fits the palm of your hand like this one. And what significance does it have just by itself? But this little part actually had the power to save a baby's life. This little baby, when he was born, his trachea kept, the breathing tube kept collapsing. And so they needed to come up with a solution to keep it open. And at the University of Michigan in the US, they use our software, the engineering department. And the engineering department collaborated with the medical hospital there, and they came up with an idea to create that little part and to put it into the patient. And it's biocompatible and biodegradable. So as the baby grows, it will start to incorporate and be a part of the baby, and it won't need to go in and do surgery and take it out. And so this picture was when the baby was in the hospital. It's now 3 years later. And it was up until that time before we started talking about it, because we wanted to make sure that the baby was doing well. That's the power of the technology, applied, multidisciplinary, and putting people's ideas together and not thinking within our own minds. It also has the power to give back a life. What I mean by that is this is hard to look at in the medical field, but it's an actual person that had to walk on the streets. But layer by layer, we're able to give back the structure and the function of his body by modeling his face, creating implants that snap into place and rebuild the structure of his face, to the point where you can get so close to him and you can't even tell that he was rebuilt. He has his life back. He can play with his grandchildren. He can go down to the corner store and not everybody's looking at him. What we do is we bridge the gap between, if we're talking in the medical field, from medical to engineering. In the medical field, doctors typically are used to looking at a 2D world. If you think about any time you've gone to the doctors, you've gotten x-rays, they look at things in a 2D world. They're looking at our body, which is 3D, and they're just making decisions in 2D. Engineers, on the other hand, have been working in 3D for years, right? So what we need to do is bridge that gap between the two, and that's what the Mimics Innovation Suite does. It bridges the gap, and it takes that 2D and it brings it into a 3D world, that now we can talk together, we can communicate, and we can come up with solutions that are better than they were individually. Here's an example of going from 2D to 3D. For example, this implant was created, and as you see in 2D, looks like a perfect fit. Let's go forward. Let's implant it. The design is exactly what we need. But that's where the beauty of 3D comes in. If you look in 3D, it didn't fit. It was going to break through the bone. And that wasn't possible. That wouldn't have been seen until after they were in surgery, and it was too late. That's the beauty of 3D. Also, it can be used not only in orthopedic, but in cardiovascular, looking at flow analysis, studying FEA, looking at new designs for valves, stents. Also, reconstruction, looking at doing research to decide what's the best approach to do surgeries, being able to actually move the jaw and plan surgery in a different way than would have been possible before. Starts with the 2D, goes into the 3D, and you come out with a 3D model. And companies like Abiomed in the US are using this to decide on the fit if a patient's a candidate for this artificial heart. And then they know for sure. This is not the kind of surgery that you can turn back on. So whether it's creating a design of a new implant, or optimizing the design with FDA, or it's planning a new surgical or researching a new surgical method and testing the fit of an implant, all of it's possible today. So how does Materialites do all this? I talked about art, I talked about industry and cars, I talked about medical, biomedical research, I talked about clinical doctors going into surgery. how is it possible in one company? What is the structure? Well, the structure is based on the 3 cores that I mentioned. And we have 2 divisions which are consumer-based, 3 that are industrial, and 3 that are clinical. So 2 clinical, 1 biomedical, and all of those work together, all based on the same cores that I went over with you. Additive manufacturing, medical imaging, and digital CAD. So, okay, has Materialize been successful working in this environment? Well, this is from our inception, the growth that we've had in sales. And it's, as you see, started out slow, but now it's something that's being accepted all around, and that's one of the reasons we're starting to see in the press. But also in numbers of people. We've seen the growth. First started out in Belgium, moved throughout Europe. In 1996 came to the US, moved throughout Asia. And now all around the world, this kind of technology is being spread. So we're really a part of the next industrial revolution. And you can see it all around you, you hear about it, you talk about it, and it's really changing the way we do things with additive manufacturing. And what Materialize is doing and wants to do more of is empower people with the tools and the knowledge to be able to make that leap into the future. And just to end, I want to show you a short video. It's going to kind of take all of our technologies together and show you how we used it to do a display of King Tut in New York. Okay?
Mm-hmm.